Hello and welcome. So today's video is about polygons. So the name polygon comes from two parts. Poly, it refers to many things. And gon actually gets its name from angles. So we're looking at shapes with many angles. You might be familiar with things like triangles, rectangles, pentagons, hexagons, and so forth. That's what we're looking at. But there's going to be a wider variety when those shapes are quite, irregular or not perfect. And so we're going to work our way through it, and there are many ways of classifying these shapes. So rather than thinking about these classification categories as exclusive to each other, try and think of it as many of these classifications can actually overlap, so they can all occur at the same time. So that'll make sense at the very end where I do some examples, but just hold on for a moment and we'll get stuck in. Let's do some basic terminology so that when I'm referring to features of these polygons, you know what I'm talking about. So we obviously, the boundary of the polygon or boundary of the shape, we refer to those as sides. Okay, you might hear me use the word edges by mistake, but we should be referring to them as sides. And where two sides meets together at a point, we call that point a vertex. Okay, so vertex is a singular. The plural of that word is vertice or vertices. So if I'm talking about all of the points on a shape, I will call them vertices. And hopefully you'll be able to pick up that along the way. Now, a polygon is a closed shape, of course, so a closed shape. If it's not closed, so if we've got something that has a bit of a break in it, now we're just looking at a squiggly line, really. So I got an example on my iPad, which you're looking at right now, which is more just like a scribbled line and not a polygon. Let's do our first category. Okay, we can classify them as convex or non-convex. Convex, now if you're like me and you wear glasses, you might be familiar with convex because our lenses, they actually curve outwards, okay? Same sort of idea happening here where the vertices, if they're all pointing outwards as if they're being pulled outwards, then we're looking at a convex shape. However, if one or maybe more than one vertex has been pushed in, like it's been hammered and we've now got a dent, well, now we're looking at a shape that is non-convex because not all of them are pointing outwards. Next category, we can say, are they regular or irregular shapes? Now, a regular shape, think of it like a perfect shape where all the edges are neat and they're all the same length. Or you could consider the flip side of that property and say that all the interior angles are identical to each other. So either or. So if you make all the angles the same, the side lengths will automatically be the same length. Or if you make all the side lengths the same, that'll automatically make all of the interior angles the same. It's weird, I know, but just take it as fact for now. If one or more of those sides are just not the same as the others, then we're looking at an irregular shape. All right, let's go to the next one. Oh, of course, the most basic, we can classify them by the number of sides that these shapes have. So the smallest polygon shape we can get is a triangle. That means 3 sides. If we get 4 sides, well, here's where we might have to expand upon our definition. So quadrilateral is the broad word for all shapes with 4 sides. Now you might be going, well, what about rectangles? Can't we use rectangles? Well, rectangles imply that you're dealing with a shape that has 90-degree interior angles. However, some quadrilaterals or some shapes with 4 sides, they can be different angles, and they can be really, really different. So we need a broader word than the word rectangle. So we've used the word quadrilateral to mean all of the shapes with 4 sides. If we've got 5 sides, it's a pentagon. 6 sides, it's a hexagon, and so on. As you get down to the bottom of the list, we get 10 sides is decagon. Deca as in decade for 10 years. Most people know that one. When we get above 10, we now have undecagon and dodecagon. So what's the deal going on here? Well, we had a bit of a debate as students in the classroom, and one of the students said that the prefix un comes from, he said Spanish, and another student said it's kind of like French as well. So un is the prefix or the word for 1. So if we try and unpack that, we're basically saying 1 and deca next to it, so 1 and 10 together makes 11. I presume we've got something similar for dodecagon, where do, perhaps it means 2. I don't know Spanish, but let's go with that idea for now. One more thing. is that let's say we have multiple shapes on a diagram. Okay, so if I've got, let's say I've got a diagram like this. Okay, and on that diagram, I have at least two shapes here. I've got the pink one, and I'll have a blue triangle. And you might need to refer to one of those shapes. Or I know you could say the rectangular one, quadrilateral, the triangle bit, yeah. But maybe the diagram's more complicated where it has multiple triangles in it. So maybe here's another triangle happening and we need to specify which triangle we're talking about. Well, in those occasions, we can actually start to refer to things specifically by their vertices. So let's put some vertices on this one. I'll use black. So I'll go A, B, C, D, and E. I might actually neaten up this diagram here, so take away some of the excess lines here, just to keep it a little bit cleaner. Okay, so now that I've put some labels onto those vertices, now I can actually refer to the triangle. The way you refer to a shape within other shapes is to start somewhere. So I'm going to pick on B. I'm going to start with there. And once you where you start from, you got to pick, do I go clockwise or anti-clockwise? It's your choice, as long as you stick to a singular direction when you list out all the letters. So I'm going to go this way around. So I'm going to go clockwise. And so I would say the triangle BCD. That's how I would refer to just the triangle part. If I want to refer to the pink area, the quadrilateral, then I would say the quadrilateral. And now I've got to name it too. So let's go, where am I going to start from? Well, let's clean this up a little bit here. Maybe I want to start from A. And again, I've got to choose. Do I want to go clockwise or anti-clockwise? I'll go anti-clockwise just for now, just to show that it's possible. Okay, so that's the order I'm going to list out the letters. So I would say the quadrilateral A, E, D, B. So the order that you list all of these letters, they have to be in a continuous direction. You can't just, I can't go from, let's counter example. I can't go from A to D to E to B. That's going to be nonsense because the person who's trying to follow you is going to go A, E, D, and they're going to trace it out and see which one you're talking about. So you must maintain direction. All right, let's jump into a few questions to practice on. Here, identify and classify the following shape. Well, one of the first things that I try is let's examine how many sides it has. So let's classify it by the number of sides. 1, 2, 3, 4, 5, 6. So we're looking at a hexagon, because that means 6 sides. Is it convex or non-convex, meaning are all the vertices bulging outwards? No, we've got a dent in this direction, so we clearly have a non-convex. So non-convex. Are we looking at a regular or irregular shape? Well, not all the lengths are the same size, so this is an irregular shape. So non-convex, irregular, hexagon. Now, the order that you list these things doesn't really matter. I might put hexagon as last. I don't know, it's up to you, but I think hexagon seems to make the most sense on the end. But that's sort of the way I could do it. Or I could start with the word irregular. I could say it's irregular, non-convex, hexagon. I think those two arrangements are still fine. Next question, how many sides does a nonagon have? Nonagon, well, if we refer to the table that we had earlier in the video, which had all the different number of sides and what name it has, nonagon means 9 sides, so that's the answer, so 9 sides. And here's one more, so state the type of polygon. So type of polygon, that's a bit vague, but we can work on that. And name it using vertex labels. Okay, so we know we have to do things like triangle ABC, for example. Let's give it a shot. Well, let's go with number of sides. 1, 2, 3, 4, 5. So we're looking at a pentagon. And we have to name it using vertex labels. So let's pick a letter. I'm going to start with A because it's the side of the alphabet. And I'm going to maintain direction. So I'm going to go clockwise. So A, B, C, D, E. That's how I would name the pentagon shape, A, B, C, D, E. Now, the type of polygon is a little bit vague, so it could be asking us, is it a convex, is it regular? So we may as well just throw that in as extra. It doesn't hurt. So I would say it is a irregular because not all the lengths are not all the same. So irregular, it's convex because all of my vertices are pointing outwards. So convex pentagon A, B, C, D, E. So that's how I would choose to name it. And hopefully from these little examples, you can start to see that there are many shapes out there for polygons. We refer to them by their shapes, refer to them by the number of sides, and the vertices are important when we're talking about specific shapes within a larger diagram. And I hope this is useful to you when you get into chapter 9b and so forth. And I'll catch you in the next video. Thanks for listening.